Hello friends, this is Chellas Katrunar, motivate others to learn. In this video series, you will learn about Six Sigma. So let us start with history of Six Sigma. So what is Six Sigma? So it is a methodology to solve the complex problems. So other problem solving tools to solve the normal problems. So but it helps to solve critical and complex problems. And it eliminates the cause of defects critical to customers. And it is the tool which helps to improve the business processes from the current level to next level. So it's a management strategy to use statistical tools to achieve break even and profits. So this is the process where we are using, so many statistical tools to solve the problems. So that is what it is given here. And next one is it's a CFT approach project. So it impact the bottom line. Bottom line of the organization means it's a profit of organization. And final one is it motivates employees to solve the problems because it is having a system of certifications and belt. So that concept motivates employees to solve the problem and achieve the certifications and belts. So let us understand history of Six Sigma. So in 1979, quality circle was introduced, and 1980s TQM, total quality management concepts were introduced, and 87 ISO 9000 was invented. So 1988 the benchmarking concept was introduced, and the best practices were benchmarked all across the industries. So the balance score concept was introduced in 1990s. So this is the quality evaluation year by year. So in 1986, the gentleman named called Bill Smith, he invented the Six Sigma process. He was VP and Senior Quality Management at Motorola. So he invented the Six Sigma concept, and he is called as a father of Six Sigma. And finally in the 1991, so it was formally launched by Motorola. So Motorola is the first company who invented and adapted the Six Sigma process and Six Sigma culture. So later it was followed in other organizations like GE and Honeywell. Let us understand some quality gurus' contributions towards the quality. So first one is Philip. He invented the senior management involvement and four absolutes of quality management. And Edward Deming, we have heard his name a lot. So he invented the PDCA cycle. And Orman, he was the person who introduced the TQM. And Ishikawa is the person who invented the cause and effect diagram, that is a fishbone diagram. And Joseph Juran, he introduced the Pareto concept into the quality field. Even Edward Pareto, who invented the Pareto concept, but Joseph Juran introduced this concept into quality and problem solving areas. And Shewhart, everybody knows the control chart and ascertainable cost, the terminologies. It was invented by Shewhart. And Tauji, that's a DOE, that's the greatest tool of critical problem solving, the problem which was contributed by multiple factors, that is being addressed in DOE. And the next and the great person is a Bill Smith, who introduced the term Six Sigma. So the terminology of Sigma, standard deviation, and converting into the name of Six Sigma, he was the person behind it. And the Michael Harry, he was the person part of Bill Smith's team, and he helped Bill Smith to completely develop the Six Sigma methodology and launch the program of Six Sigma. So these are the people majorly we know already before entering to the Six Sigma. So let us understand some terminologies here. sigma, that term means standard deviation. So before going into that, let us understand few more terminologies. So if you are arranging the numbers in the sequence, so middle value is called median, and most frequent, I mean multiple times repeating numbers called mode, and average values called mean. I mean summing all the numbers and dividing by total numbers taken is called average, and that is called mean. So if you are just taking a data, if you are plotting 50 numbers reading of any machining product dimension, so this will form a graph like this. So that is called normal distribution, because the data will be normally distributed on both sides of mean. Mean means average of the readings taken. So in the curve, normal distribution curve, the area of the curve is divided with unit of sigma. So if we look at one sigma in the both sides covering 1 sigma, the 68% of area is covered, and in the 2 sigma 95% area is covered, and in 3 sigma 99.73% of area is covered, and reaching to 6 sigma, so 99.99998% of area is covered in the normal distribution. So these are the data randomly taken and independent data. Examples are height, class members, dia of punching hole, and any dimensions of machining part. It may be the manufacturing data, or it may be any service data. At any data, if you are plotting that data into the curve, in the normal distribution curve, so the spread around the mean is called standard deviation. The standard deviation, taking that unit and categorizing into a 1 to 6 sigma, that area covered in this 6 sigma will be nearly to the 100%. So if we are converting this area into rejections, so that means if it is a 1 sigma, so within this area of 1 sigma all the parts will be okay. Beyond that, if it is not okay, so that if you are converting into rejection rate, so like we will go into the parts per million, that means 1 million parts produced, and in that 1 sigma category 6,97,062 parts will be rejected, and 2 sigma category 3,08,770 numbers parts are rejected, and further you can understand from this table. And 5 sigma only 233 parts will be rejected, because this much quantity will be out of this area. So in 6 sigma category, only 3 parts on per 1 million production only will be rejected. 3 parts out of 10 lakhs parts production only will be rejected. That means, so the 6 sigma area is only 3 parts, 3 defects will be found. So that is what the process which achieved the 6 sigma level, it is called as a error free or defect free process. It's a best process to benchmark. So that is what this terminology of 6 sigma has been taken for problem solving and improving the process from the current level to extreme best level. Friends, thanks for watching the video and hope you like this series of 6 sigma, and please comment your expectations and learning so that I can cover in the further videos.